All right, so we're going to go over maximizing area and perimeter for four-sided shapes specifically. So this is very vague because I kind of just stole the important parts. We have 82 meters of rope. We got to find the max area that we can enclose that would make a four-sided shape. So we could technically play a game of a table here, right? And we could have, oh, here's your length, here's your width, and we can kind of run through all of the options with this. Options being, we got to make a four-sided shape. So I'll just kind of give you a general idea. Here would be like an extreme, and you kind of tend to start with extremes. Let's say this is 1 meter, and this is 1 meter, okay? Well, that means 2 meters are used. So I still have 80 meters left. Does that idea make sense? We started at 82, so we used 2 meters, so now we're left to 80 meters, and I still have 2 sides. So if I divide it by 2, the 2 sides are 40 meters each, right? So this is 40 meters, and this is 40 meters, because they gave us 40 or 82 meters of rope, and essentially they're saying give 82 meters to build a perimeter. Well, that would give, we'll call this 40, this one, gives you an area of 40. It's not so great. So then we can start building less extreme shapes. So, you know, this is a little wider and a little shorter. We get a less extreme shape. I guess we'll go through it so you can see the concept. So say this one is 2 meters, but it's not quite as long. I'm going to do a little mental math as we go through it, okay? Remember, the total perimeter is 82, okay? So, with that being said, if this is 2 meters and this is 2 meters, we've used up 4 meters, okay? So we subtract 4. We're left at 78. So 78 between the two, we divide it by 2, we get 39 meters, okay? 39 meters and 39 meters. If you want to check on your calculators, you can. 2 times 39 gives us 8, carry the 1, 78 as an area. So right away, by area I did length times width, right? So 40 times 1 gave us 40. 39 times 2 gave us 78. That's a huge increase in the area, okay? And this pattern continues and continues until it gets to a specific shape. And what is that shape?
Square.
A square. Essentially, the most efficient shape we're going to build is going to be a square of our four-sided shape. So to be extremely accurate, instead of going with whole numbers, this is what we're going to do. Because we know squares, sides are all the same, right? That means the length and the width are identical. So if I said the area of the square is equal to the length times the width, well, I know they're the same. So I don't really have to give them different letters. I can call them both L if we really want. Does that idea make sense?
Mm-hmm.
Okay. So area equals L times L. How can I simplify that? L times L. Do you guys remember your exponents? Like simplifying?
Oh, yeah.
Exactly. So the area squared, or area is equal to L squared. Well, we know the area. The area, sorry, do we know the area? Oh, no, we didn't know the area. Okay, this is good if they've given us the area. In this one, they gave us a perimeter. And we use a different formula. Still same concept. Perimeter is 82, and a perimeter formula is P equals 2 times L plus W. Okay? But we just talked about here, L is the same as W, so we don't need to use W. We're going to use L instead. It's L plus L. Does that make sense? Are you okay with that formula? How can I simplify L plus L?
L squared.
Well, we're adding them instead of multiplying. If we multiplied, it's squared. If we add them,
2L?
Perfect. So we get P equals 2 times 2L. Do you know what that becomes when multiplied? Yeah, 4L. Boom, there we go. And we know what P is. They told us we had 82 meters. Oops, there should be a 2 in there. There you go. 82 meters. So we're going to plug that in for our perimeter. So 82 equals 4L. So what's our length? Well, we isolate for L. So when we bring the 4 over, it becomes division. So it's 82 divided by 4. So it's going to actually be 20.5. You can check with your calculator if you want. So 20.5 meters is apparently the best we can do with our rope. 20.5 meters by 20.5 meters. And if we check, we kind of write it in. 0.5, 20.5, and we multiply them to find area. We'll take our calculator out here. 20.5 squared. Much bigger area. Look, they were working with 40, 78. We're at 420.25. So a huge number, right? for 20.25. I don't know why I crowded myself like that. Okay, so what we've discovered is that the square is the best shape, and when we're given the perimeter, we can plug values into this formula and just isolate for what our L is going to be. And in fact, if we had just used the original numbers and we were going up by whole numbers, we would have skipped it. At one point, we would have got to like 21, and then we would have jumped to 22, or we would have had 19. We probably wouldn't have guessed 20.5. So this will give us a very exact formula if we can go through the perimeter formula. Okay, so with that same idea, here's our part 2. We have 82 meters, but we no longer have ropes, so it's not very malleable. They've given us barrier, and each barrier is 2 meters long. So if we recall from what we just did, to build a square, okay, like we were saying, it's not malleable. Each of them is 2 meters long. So we discussed how a square, if we work out this perimeter, it ends up being perfect at 20.5, right? But my problem here is if I have 2 meter long every time, I can't actually get a 0.5. That's not possible. So I have to work with our chart. Okay, we can't strictly use a formula. We can jump ahead. Because we have obtained information, we know numbers around this are going to be best. We're going to work with values that would be around that. Okay, so let's say we have a length and a width, right? And 20 was a pretty good number here. So we have 82 meters of barrier. If I have a length that's 20, okay, so this is going to be just a bit different. This shape is not quite a square. Okay, if this is 20 meters and this is 20 meters, and remember we had 82 to start, so we kind of got to go through that trial and error again. 82 meters to start, and I subtract by 20 and 20, so essentially I'm subtracting by 40. That leaves me with 42 meters. Okay, I have to split it between 2, so I have to divide it by 2. So each of those sides have to be how long?
21 meters.
21 meters. Can I even do that?
Mm-hmm.
Well, the problem is 21, which would be really nice. That's probably the next most efficient. Yeah, actually, I think that does give us 420. The problem is, if everything's 2 meters long, I can't build 21 meters, right? Because I go up by 2s. I either have a 20 or I have a 22. So I have to look for multiples of 2 as we go through this. So we're going to have to jump down again, okay? Let's take a look at what we got here. Let's say I go into the value of 18. Okay? Let's see if 18 will free up some more space. And maybe it won't. Maybe it'll keep giving us odd numbers on the other side. So if we have 82 meters, and both of these are 18, okay? 18 and 18, do you know what we're going to add when they put them together? What they'll become?
36.
Perfect. They'll become 36. So we have to subtract 36 from 82. You guys want to take your calculators out? Try it. I got it here. Okay. This is what good is. When you don't have it, when you know your subtraction rules, boom. 46. 46 meters is what we have left. We got to split it in 2. If we split it in 2, what happens?
23.
23. We run into the exact same problem we did last time. Can I build 23 with 2 meter long barriers?
No.
No, I can't do it. I'm getting really, really stuck. Okay? So, in order to do this, what I'm probably going to have to do is I might have to actually just not use a section of barrier. This 82 is not working out for me. What's happening is I'm always having like an extra barrier in the way, an extra 2 meter barrier. Okay? So it might actually make sense, you know what, this 2 meter barrier, because everything's like very solid, right? It's not like I can cut it. Well, in real life I probably could. Let's just say I'm going to throw out one of the barriers, and I'm going to work with just 80 meters, okay? Can you think of values that might work out really, really well at 80 meters? And remember, go back to efficient shapes. What can we do with an efficient shape?
20.
20. We can do 20. And 20 is probably really close, right? It would be like here, 0.5 less, and that wasn't so straight, 0.5 left. But 20 meters by 20 meters by 20 meters by 20 meters gives us our 80. And we kind of have 2 meters of barrier left over, okay? But that's fine, because that's going to be a max area with a little bit of barrier left over, okay? It wasn't quite as good, but it's better than any of our other options because we're stuck. We can't actually make our options, right? Because we keep getting odd numbers, and with 2 meters of barrier, we can't build those odd numbers. So the rope is a little bit better than our non-malleable barriers here. Okay, and let's kind of look at the double page.